Hey AP Calc, and welcome to the section 5.5 Trapezoidal Rule Flip. So we're going to do the same thing we've been doing. We're going to squeeze shapes under curves and try to estimate how much area is accumulated. Keep in mind this is just an approximation. Okay, we're still in an approximation, not the exact integral yet. So instead of squeezing rectangles in the curve this time, we are going to put trapezoids in there. So what's interesting enough about trapezoids is obviously that side right there that can curve. So we're going to be closer and closer than our Riemann sum. So to do this, consider this trapezoid right here. Okay? Regarding this trapezoid, its height is the vertical distance from here to here. Okay, this is the height of the trapezoid. This distance over here is B1, and this distance right here is B2. Okay, so base 1 is on the left side over here, and base 2 is on the right side over here. And the height is the vertical distance. So recall the formula for the area of a trapezoid. 1/2 times the height times the sum of the two bases. Well, what you have to remember about this particular formula is B2. You see B2 on this trapezoid right here? It's actually going to also be included on this trapezoid, the rectangle. It's the left side. It's the base 1 of this trapezoid. So interestingly enough, things are going to repeat here. And to better observe that, we're going to build our formula for the trapezoidal rule. Well, let's start with this. What are these trapezoids going to have in common? Well, they're all going to have the 1/2 height in common, right? 1/2 times the height. So if you factor that out, it brings up the following formula. 1/2 times the height times the sum of all the bases. But interestingly enough, B2 is going to be located twice. B3 is going to be located twice. B4 is going to be located twice. And all of them are going to be located twice except the first base and the last base. So if you refine the formula a little more, it brings out the following. 1/2 times the height times B1 plus, you're going to double all bases up to the very end, but not including the very last base, Bn. Okay, so take a moment, write down that formula. Okay, so interestingly enough, let's talk a little bit about over and under estimates with these guys. Okay, so let's consider first of all this piece right here. This whole stretch of the curve is a concave down curve. Understand that when the curve is concave down, the trapezoidal rule will give you an underestimate. See all this little wasted area there? That's an underestimate. You're not quite there yet, okay? And also keep in mind when you have a concave up curve, like this piece right here, you have, thank you, you have an overestimate. See all this area that's included here that should not be included? So that would be an overestimate, okay? Let's do a problem. So this particular problem says, let T of n denote the approximate trapezoidal sum with n subintervals. Use T4 to approximate the integral from 0 to 2 of x cubed dx. Okay, so in order to solve this problem, our region is 0 to 2. We're doing 4 subintervals from 0 to 2. So that's pretty easy to visualize. The height is going to be 1/2, right? So we've got 0 to 2. We've got 1. We've got 1/2. We've got 3/2. We've got the curve that looks a little something like this. A little too steep towards the end there, not steep enough in the middle. Let's try again. Let's get like that guy. There, that's pretty good. And then we have the curve itself. So boom, boom, boom. These are my trapezoids. So I've got trapezoid number 1, trapezoid number 2, trapezoid number 3, and trapezoid number 4. So the height is all 1/2. The height, the height, the height, the height is 1/2, okay? So let's start building our formula. Area equals 1/2 times 1/2. Okay. Now let's take a look at what the bases would be. So you have to use the curve itself, the x cubed piece. So if we look at the very first one, we'll use this wacky pink color, would be right here. Well, 0 is the B1, and 0 cubed is 0. So if we continue our formula, it would be 0 plus. Now we're going to start doubling, because this distance right here, which is going to be my B2, it's my B2, my right base of my trapezoid 1, but it's also the left base of my trapezoid 2, so it's included twice. Now, what is the value? Well, it's 1/2 plugged into the function x cubed, so it would be 1/2 cubed. Oh, we'll go back. 1/2 cubed, which is just 1/8. Plus, here we go, next one. This is my right base in my trapezoid 2, my left base in my trapezoid 3. So it is being repeated also. So I have to use it. The value is 1. So I just cube 1. That's easy. And last but not least, this guy is the last side. It's being doubled. Now it has a value, an input of 3/2. I'm going to cube 3/2, and I'm going to get 27 over 8. Plus the very last base that I only use once, I don't double this one, is just 2 cubed or 8. Okay? So if I calculate all that, it comes out to 1/4 times 17, which is actually 4.25. This is my approximate area for the area under the curve x cubed from 0 to 2. Now, interestingly enough, if you actually calculate that, the integral from 0 to 2 of x cubed dx is actually 4. So the trapezoidal sum did give us a number that was relatively close, not a bad estimate. Now in class we did study one thing that was interesting, and that is what is the average of LRAM and RRAM. And we kind of speculated, well, is it MRAM? It's not MRAM as we saw in class. It's actually the trapezoidal approximation, which is a very interesting fact. So this will come in handy when we start to kind of relate the magnitude of LRAM, RRAM, trapezoidal, MRAM, where do they fall, which one's bigger, which one's smaller, things like that. So very interesting. Let's end with one more problem. Let's look at this one. It says some values of a continuous function are given in the table above. The trapezoidal rule approximation for the integral from 0 to 10 of f of x dx is. Okay, so I'm doing a trapezoidal approximation. It looks like I have 11 entries here because I include 0, so 11 entries. So first, let's consider h. Well, h is the distance between each of these values. So it's just 1. So area equals 1/2 times h times, okay, b1 is not doubled, so times 20, plus, now we double all bases in between, because the right base of my second trapezoid and the left base of my third trapezoid will both be 19.5, so I have to double the 19.5, plus I double the 18, b3, and this goes on until I get to the very end, which is the negative 20.5, and I stop doubling, and I do not double the very last one, which would be the B11, which would be the minus 30. Okay? And if you compute this all in a calculator, you're going to get that the area is equal to 32.5. So it would be choice B. All right? So that's a little bit of the trapezoidal rule, so add that to your toolbox, and let's keep going.